record the, yes, now. Okay, Leonid, I'm going to introduce you to the group. We had here Professor Leonid Zotov. I met Leonid Zotov when he was a Fulbright visiting scholar, you see, a few years ago. He stayed in United States for a year, and we invite him to come to Puerto Rico, and he liked it very, very, very much, Puerto Rico. Okay, so also he invited me 2 or 3 times to go to Moscow. Okay, so he showed me Moscow State University, the beautiful city of Moscow, many places interesting very much. So we had a good partnership with Leonid, and I'm really glad that Leonid accept, you see, the invitation to talk about what he's an astronomer, so he knows a lot of stuff that we don't know. So that is going to be his talk, and also we are going to record this presentation, and we are going to present it to other people, okay, in the Americas. All right. Okay, Leonid, the mic is yours, so you can do whatever you have for us today.
Okay.
Right.
Can you see my screen?
Yes, we see it very much
Okay.
with a
Then
picture.
let me start.
Yes.
Sorry, I was thinking how to make astronomy so short, because I'm teaching a course of 12 lectures in Moscow at Higher School of Economics. And if I won't fill in half hour, excuse me, but I'm sure it won't be, it will be interesting for you. I will start with ancient times. Here you can see um, firehouse of Alexandria, and ancient astronomers, probably Hipparchus. We know Seneca, the teacher of Neron in ancient Rome, wrote, "If the stars could be seen from only one place on Earth, people would travel there in droves to admire the sky." Why people's eye can see the stars? Why it's necessary for us? Maybe because our predecessors had to navigate using the stars. Anyway, it's a great gift of nature to us that we are able to see them and to think about the universe. And great philosophers presented at this Raphael Athens school, Pythagore, Plato and Aristo. They were also great philosophers, great thinkers, developers of science, ancient science. And this picture shows us not only philosophers, but astronomers in the right bottom, because astronomy and philosophy, they are very much related to each other. And we can read ancient books, for example, Works and Days by Hesiod, ancient poet, where they speak about stars. For example, they speak about Pleiades, a small group of stars, so-called asterisms, well seen in the constellation of Taurus in the sky. And we find artifacts, for example, the sky disk from Nebra, dated by the 17th century before Christ, where you can see these 7 stars. In Works and Days, Hesiod related astronomy with calendar, with seasons, in what season which stars appear in the sky, what people should do, gather harvest, or sail in the ocean. This is the meaning of these times and dates. and Pleiades is a very beautiful asterism in the sky. I'm sure in American culture, it's also a selected group of stars. Try to find them by yourselves in the sky. There are old megaliths found on Earth. For example, in England, there is a great Stonehenge dated as 3100 years before Christ. This megalith is related to astronomy. It is written by John Edwin Wood in his book Sun, Moon, and Standing Stones. This author is one of the developers of archaeoastronomy, that many ancient buildings, ancient megaliths had orientation related to the solstice and equinoxes, the day of rising sun in July, in December. It was very important for ancient thinking, for ancient religions and philosophy. So astronomy has very deep roots. It is related almost to all the fields of human thinking, human sciences, to history, to archaeology, to mathematics. For example, this is the orbit of the Earth. Sorry, I use some Russian words here. And we know that the axis of the Earth is inclined to this orbit by 23.5 degrees. Thus, we have a change of seasons. For example, in Europe now it's summer, July. In Latin America, it's winter now. And there are days of winter and summer solstices, which for ages was a very important cultural days. And if we point the yellow orbit of the Earth around the Sun, it's called ecliptics. We will point by orange the equator of the Earth, which is perpendicular to the axis of the Earth's rotation. We see northern pole, southern pole. Maybe we don't see it here in Moscow, but I was in South Africa, like Juan, and I saw Octan and famous Southern Cross, sorry, Crux constellation. Sorry for my English. These are the major things important in astronomy because Earth rotates, but we see how the stars rise and hide below the horizon, how the sun rises and falls, how the moon goes in the sky. These are important things for ancient astronomers and for contemporary astronomers, of course. And you must see the sky differently from different latitudes and longitudes. For example, if you stay in the southern hemisphere, horizon, orientation of your horizon will be different from, for example, if you live in Bolivia, if you go to Cape Town, and the view of the sky, the rising stars, culminating stars, and stars which never appear above the horizon, there will be different. And if you study astronomy, you must know where you observe the stars on Earth. For example, now in the northern region, above the polar ring, there is a day, there is no night at all. I visited St. Petersburg in June, and at night, it never dark enough to see the stars. It's called white nights. But in Antarctica, for example, now, there is a polar night. You cannot see the sun rising above the horizon. tropics of Cancer, tropics of Capricorn. I don't know, maybe Bolivia is somewhere near between equator and Tropic of Capricorn. So it all depends on this inclination of the axis of the Earth by 23 degrees to the ecliptic orbit of the Earth around the Sun. By the way, when Earth orbits the Sun, image of the Sun appears at different constellations. These constellations are known as zodiac circle. We know them very well. There are non-scientific speculations from astrologists about who was born in which month belongs to the particular zodiacal sign, and we know this is just constellations ecliptics pass through. There are 13 constellations. One of them, Ophiuchus, it doesn't belong to the circle of 12 zodiac signs, and this is well known by astronomers. In which date, try to find your birthday. You will be surprised. You will be surprised because there are different extensions of time, different from what astrologers say, when the Sun comes to the particular constellation of ecliptics. And when when Earth rotates around the Sun, in January it is closer to the Sun, 147 million kilometers. In July, now, it is farther from the Sun, 152 million kilometers. That's why summer in boreal summer in northern hemisphere is not so hot, and winter in northern hemisphere is not so cold. And these points are perihelion and aphelion, and velocity of Earth is also different. It goes quicker and in the closest point in perihelion, 30.2 kilometers per second, and it goes slower in aphelion because of the laws of celestial mechanics. You must know that in astronomy, this distance, radius of the Earth's orbit, is named one astronomical unit. Astronomical unit is 150 million kilometers. Astronomical union also exists, and it has general assemblies, and one of them happened, it seems, last year in South Africa. Maybe we'll have astronomical assembly in Bolivia as well. This picture shows how the Sun rises and falls in the northern hemisphere. In the southern hemisphere, the picture is different. For example, in the northern hemisphere, the shadow of the, let's say, this obelisk in Paris, it goes clockwise. But in the southern hemisphere, it will go back, not clockwise, but opposite to clockwise direction, the shadow of the Sun. And using the height of the Sun and how it goes, we can make solar clocks. Solar clocks are very ancient development, invention by humans. They are not very precise, but anyway, we can even date the season using solar clocks. Try to make them by yourself. Anyway, today we have many programs: Stellarium, Redshift, Google Sky, Sky Guide, Sky View for Android. They help you to navigate, and even if you never saw constellations and never tried to find stars, you can use your mobile phone to find where are planets, where is the Sun now, and so on and so forth. Famous constellation Orion. Orion is one of the most, how to say, you can see it clearly because 3 stars on one line. This is called Orion belt, if you don't know. And in Orion constellation, there are also very beautiful nebulas, the Horsehead nebula, top left, Orion nebula, bottom right. And this is a kind of place where the stars are born. This is a nursery of the stars. Thousands of stars appear there. But most famous star is, of course, the sun. The sun is monitored by many satellites and observatories. For example, yesterday on the 24th of July, on the surface, on the, the side of the sun that we observe from Earth, we could see several sunspots. Sunspots, these are regions, active regions on the sun, and even sometimes solar flares occurs. For example, this is one of the solar flares happened in 2025. When solar flare appeared, the quick particles from the sun come to Earth and modulate so-called cosmic weather. Cosmic weather. Maybe you know that Earth protects us by its magnetic field, but sometimes magnetic field is disturbed by solar wind, solar particles. Then we have magnetic storms on Earth. Some old people feel uncomfortable when there is magnetic storm. It seems today there should be quite a high index, so-called K index of magnetic, of space weather. In the northern and southern regions, very beautiful aurora appears. Sun activity is changing within 11 years. And recently, in October 2024, there was a maximum of solar activity. Most of the very many sunspots appeared on the surface of the sun. There were magnetic storms. And now the sun activity is slowly decreasing. Period between maxima is about 11 years. And it, of course, influences our life, our feeling, our health maybe on Earth. What is interesting, that solar eclipses are very interesting when the moon is between the sun and Earth. For example, this partial eclipse in Beijing, very beautiful. This is a total eclipse. You can see solar corona around the sun during the eclipse. And on August 12, 2026, there will be solar eclipse. If you want to see total eclipse, when the sun will be completely covered by the moon disk, you should go to Spain this year, because this blue is a total phase of eclipse. It goes through the northern pole, through Greenland, Iceland, and then it comes to southern Europe, southern France, northern Spain. Those people who want to see this wonderful natural phenomena this year should travel to Spain. Next year will be different. Now we start to speak about the moon. The moon is the closest celestial body. Galileo painted its surface through his telescope. He invented it in 1609. And now we have many good pictures of the moon. We we know the origin of its craters, surfaces. We can calculate when there will be lunar eclipses. You know, the solar eclipse is when the moon between the sun and the solar eclipse, lunar eclipse is when the moon goes to the shadow of Earth. So all this depends on the orbit of the moon and position with respect to the sun. We had a lot of space exploration of the moon. For example, Chinese missions landed small module, and it was Chane 4. Chane is a goddess of the moon in Chinese culture. And these pictures, moon through telescope, Jupiter through telescope, was already painted in the 17th century after Galileo invented telescope. These paintings were made for Vatican in Rome, where the Pope lives in Vatican. These pictures are there by Donata Creti. Many painters, many poets dedicated their works to astronomical objects. Now we know that this month, July 2024, the moon went to the northern hemisphere on the 12th of July. Then it goes back and it crosses the equator on the 19th of July. And tomorrow, on the 26th of July, the moon reaches its most southern position in the sky. So you from Bolivia will see the moon very high. And me at my country house hardly see the moon rise for 2 hours, and then it hides behind the trees. It goes behind the horizon very quickly. Because this year it's very interesting that the closest position, letter P, perigee, is in the most northern part of the lunar orbit, and apogee, the most distant position of the moon, is exactly tomorrow at the most southern declination of the moon. In my opinion, what I observed this summer, very interesting, it seems to me that moon even influence the weather. It creates tide, and each time the moon goes to perigee, it goes very high in the sky, it becomes very hot in Moscow. But when moon goes to the southern hemisphere, to its most distant position, it becomes cold, rainy and cold. Now it's only 22 degrees in Moscow, but last week it was 29 degrees Celsius. Very strange summer. Anyway, this is just hypothesis that the moon can influence the weather. You can try to check it by yourself. But what I want to point out that tomorrow the Earth will rotate very quickly, because the tide it influences the Earth's rotation in such way that July 26 will be the quickest rotation of the Earth this year. And I gave interview, you see my name, Leonid Zotov, specialist from Moscow State University, to the internet journal Time and Date. And this Time and Date is reproduced by other newspapers. For example, this is a paper appeared yesterday in Forbes. Forbes is a journal for billionaires. You know, there is a list of Forbes. I must tell you, I do this interview for free. I don't ask $1 million for for this interview. But it's funny that many people are interested, and it is related to this motion of the moon in the sky. If we have spoken about sun and moon, we must speak about solar system because it's a subject of astronomy. This is a map of solar system exploration by interstellar probes, by different interplanetary missions. It's already half hour, but I will be quick. So Mercury. Mercury is the closest planet to the sun. It's very hot. It reminds the moon. Now we have the map of Mercury. 99% of its surface is pictured. There are studies of gravity field of the planets. And now we know that inside Mercury there is a liquid core. Now let's speak about Venus. Venus has a very it's a second planet from the sun. It reminds the Earth, but it has a very big greenhouse effect because a very complex and very thick atmosphere. Surface temperature of Venus is almost 400 degrees Celsius. From Earth, you can see Venus changing its phases. If you have telescope, you will see it's like a moon. But inside Venus, there should be some processes which activate 1.5 billion years. For example, there are evidences of volcanoes and different magmatic flows on the surface of Venus, but they are very old. 500 million years ago, planet was active. And maybe a lot of CO2 was released to the atmosphere, and now it's impossible to stay at the surface because the temperature is very high and pressure is 90 atmospheres. And even Soviet exploration missions, Venera 14, 15, 16, Venera means Venus in Russian, they couldn't live more than 3 or 4 hours. Then they were broken. Now we have pictures from Venus, but we want to send another mission to it. Venus and Mercury, they are so-called internal planets because they are inside the orbit of the Earth. Now let's speak about first outer planet, Mars. Mars orbits the Sun at an average distance of 450 million kilometers, and there is a change of seasons. One of astronomers, I don't remember who exactly, he told God created Mars exactly for us because its inclination to the orbit is very similar to ours, and it has seasons, and day on Mars lasts for about 24 hours, more or less. But the problem is that it is 2 times smaller and it's much colder. At daytime, there could be 20 degrees Celsius at equator, but when night comes, the temperature drops to -80, -100. Thus, we have, you see, this kind of desert on Mars. Of course, there are no trees on Mars. There is no plants. There are only polar caps and dust storms. On this picture, you see in the southern region the dust storm. Dust storm appears because strong winds from the southern polar cap rise the sand, and these Martian dust storms are very well seen using telescopes from Earth and of course from satellites. There are more than I would say about 10 missions walking around Mars today. Mars topography is very interesting. Red regions with volcano is exactly opposite to the this impact Hellas basin on the opposite side, reflected by blue. And Acidalia planitia, you see the northern region, northern hemisphere of Mars, reminds the bottom of ancient ocean. It could be that there was water covering Mars many billion years ago. You can see the movie The Martian, and you see he lived in Acidalia planitia there. But this is a real sunrise. It is not yellow, it is not red. It reminds something green-blue, the sunrise on Mars. There is a huge volcano, the largest volcano. Compare it with the Earth Everest and Mauna Kea at Hawaii. It is 21 kilometers high, the largest volcano in the solar system on Mars. And these are pictures made by Curiosity. Curiosity, it's of size of a big jeep, of big car, very good equipment, cameras, lasers, and power supply from plutonium reactor, which should work for 40 years at least. There is a question: is there life on Mars? There are some facts, for example, existence of methane in the atmosphere. This amount, 270 tons of methane, it should disappear in 3 or 4 years. But there is some supply of methane which could come from natural geology, or probably there are microbes inside the land, inside the ground of Mars. This question is still open. After Mars, we have in the solar system main asteroid belt. There are many stones. There were missions to them. For example, one of the largest asteroids, the second, Vesta, of size of 500 kilometers, was visited by Dawn mission. Another thing, Churyumov-Gerasimenko comet, was visited by European Rosetta mission. You see, comet differs from asteroid. Asteroid is solid, but comet has a lot of ice, and when it approaches the sun, there appears the tail. You see some gases going out of the stone. This is origin of tail of a comet. Giant planets, the king of solar system and the king of Olymp, Jupiter, with its famous red spot. Red spot exists for 300 years already. It's a kind of cyclone. It's a bit warmer than outer regions. That's why it has this color. And Juno mission is working at Jupiter. It studies its polar regions. Jupiter has very interesting satellites. One of them is even larger than Mercury. Ganymede is almost a planet. But we will say only about under ice ocean of Europa. Europa is a kind of very interesting satellite. You can observe them using binocular or very small telescope by yourself. And we think that behind several kilometers of ice, there is a water ocean, and some creatures could live there, some microbes or maybe some biological forms. Thus expeditions are prepared to visit this icy world satellite of Jupiter. After Jupiter, there is a planet with rings. Saturn. Saturn is very large. It's also very active. It has magnetic fields. You see auroras like on Earth at the polar region of Saturn. It's a system of rings are very complicated and very interesting is a satellite. The biggest satellite of Saturn is Titan. It has methane lakes. You see them. The sun is reflected and you see the rivers of hydrocarbon. The temperature is low, thus methane is fluid on the surface of Titan. Uranus, next icy world, it rotates, its axis of rotation is inclined by 96, I think, 98 degrees to its orbit. Thus, in 84 years, the seasons changes in a such way that spring lasts 24 years, summer lasts 24 years. Now northern hemisphere of Uranus is coming to the solar rays, and Uran also has system of rings. It can be seen in infrared. And Neptune is the next big planet compared with Earth here. Look at it. Its mass is 17 mass of the Earth. Temperature is minus 221 Celsius on the surface. Actually, there is no surface of such planets. They don't have solid surfaces. Jupiter, Saturn, Uranus, Neptune. And finally, Pluto, which is not now a planet. When it was discovered, people expected that it is big, like the Earth. Now we know that it is small. And mission which pictured New Horizons, this mission pictured Pluto in 2015, released for us very interesting details of this world. There are mountains, there are ices, there are even cryovolcanoes. Here you see the crater of cryovolcano and very interesting details on the surface of Pluto. Finally, around our sun, there is so-called heliosphere. Heliosphere is a region of solar wind, solar influence. Now two Voyager 1 and Voyager 2, two missions reached very distant regions from the sun, and they were sending us signals about this so-called heliopausa, where extrasolar wind particles from other stars meet the particles of solar wind. And this is the chart, the map of contemporary astronomy. How many sections, how many sciences inside this big science? Celestial mechanics, astrophysics, extragalactic astronomy, stellar astronomy, space geodesy. Are there any questions? If there is no questions, let me spend maybe 10 or 15 minutes more. Juan, do I have this time?
Oh yeah, it's an outstanding presentation. This is a
Because
beautiful.
astronomy very big. So if you let me spend 10 more minutes, I will
Yes,
speak about astrophysics a little bit.
yes, do it, please do it,
Thank you.
Leonid.
This is a picture of stellar evolution. Small stars, they exist, they live for billion years. The sun will live for 5 billion years more, then it will become red supergiant or maybe red giant, then there will be explosion and white dwarf appear from our sun. If you take the big star of 20 or more solar masses, at the end of its evolution, supernova explosion happens, and the remnant is usually neutron star or black hole. So depending on the initial mass of the star, it has different size, different luminosity, different color. Blue stars are very massive and hot. Red stars are very small and low temperature, maybe 2,000-3,000 degrees Celsius at the surface. But inside the star, there is always the atomic reaction. Hydrogen becomes helium. And if there is no supply of hydrogen, the star cannot burn anymore, and it will collapse. And the remnant of the sun will look similarly to this ring nebula in the sky. There will be this nebula, and inside a white dwarf. White dwarf is a kind of skeleton of this. It's a dead star. Such pictures, planetary nebulas, pictures made by good telescopes, show us the future of our star. But Indian astrophysicist Subramanian Chandrasekhar, you see him when he was young, and this is a picture of his older ages. In the 1934, he derived the equation for the state of this white dwarf. There are very many of them. They have the size of the Earth. 1 cubic centimeter of the star weighs several tons, maybe several thousand tons. Why? Because why this star cannot collapse further? Because the electrons, they follow so-called, I won't speak in English, this name. Anyway, there is a physical law which cannot allow electrons to stay very close to each other, Pauli principle. And there is a so-called electronic gas which makes high pressure inside the stars. But even the stars which are larger, very massive, 20, 30 mass of the sun, then they can continue this process of collapse. And after supernova explosion, for example, in another galaxies, sometimes supernova explodes. Neutron stars are remnants of supernovas often. Neutron star it's like a core of atom. The total star, the size of 10 kilometers, consists of neutrons, negatively charged particles, because electrons collide with protons under very high pressure. 1 cubic centimeter of such star weighs already for maybe tens of billions grams. And when something falls on the neutron star, high energy release, for example, if you send a bottle of cola on the surface of neutron star, there will be similar to atomic bomb explosion. Thus, neutron stars are observed as radio pulsars, magnetars, and when I visited Juan in Puerto Rico, he took me to Arecibo Observatory. It was the biggest radio observatory in the world that time. They had a lot of observations of pulsars. Now, FAST telescope in China follows these programs of observation. Arecibo is now a museum, if I'm not mistaken. And supernova remnants are nebulas with neutron stars. For example, Crab Nebula. To study these objects, we need the theory of relativity developed by Einstein. And Einstein's theory allows also so-called black holes when nothing can stop this collapse of the star, and every matter goes closer to the center, and finally hides below so-called horizon, event horizon. Black holes are objects which have attraction as a normal star, but the problem is that they are very compact, and for example, for the sun to become a black hole, it should have size of 3 centimeters, I think. Sorry. For the Earth to become a black hole, its radius should be 3 centimeters. For the Sun, its radius should be several, maybe 6,000 kilometers. What I'm saying, about 10 or several kilometers, let's say 3 kilometers. Then the mass of the Sun, if it goes behind this size, below 3 kilometers, it will go below the event horizon. And all of you know movie Interstellar, where Nobel Prize winner physicist Kip Thorne, together with supercomputer team, made model of rotating black hole with accretion disk around it. This kind of disk appears when matter fall down to the black hole, and energy releases very big energy, up to 40% of the mc squared, mass of how to say it in general relativity. I forgot this English name. Mass of non-moving mass, how we call it. Thus, we have projects, optical telescopes, extremely large telescope will be built very soon in Atacama Desert in Chile. And we, of course, have radio telescopes and multi-wave astronomy on spaceships, on satellites, X-ray astronomy, Röntgen. And this is our Milky Way, our galaxy, 200 billions of stars in one disk. At the center of Milky Way, scientists mapped a black hole of 4.5 million sun mass. It is mapped using so-called telescope of event horizon, radio telescopes, including one in Shanghai and in Australia, in the United States. They mapped this black hole. This is supermassive black hole. Stars orbit this region, you see on the left, in 15, in 20 years, which, according to the Kepler law, allows us to measure the mass of this object, 4.5 million solar masses. Now, almost the end of my talk, you'll see the scales of the universe. Interstellar sizes like several hundreds or thousand light years. The size of our galaxy, 200,000 light years. Our closest galaxies, including Andromeda galaxy. These regions are already form superstructures. Each point is a galaxy. In 1929, Edwin Hubble together with Georges Lemaitre, French, I would say Catholic. He was actually the priest, Catholic priest, but he was very interested in cosmology, this section of science. They discovered the expansion of the universe, that distance between galaxies increases because the space itself increases. Now, when we see many galaxies, for example, at this Hubble Ultra Deep Field image made using space telescope, you see the exposition started in September, ended in January. It lasted for 4 months. The telescope observed one and the same region. You see thousands and thousands of galaxies, and some of them are very distant. And cosmology, the science which studies the expansion of the universe, how it appeared, it is very interested in very deep objects because they say us how, you see, the light takes time to come to our eye. Sometimes light need to travel billion of years to come to us. And thus we see distant objects when they were very young. Now we know that age of the universe is about 14 billion years. And some galaxies here we see very young. They are more than 12 billion years old. And finally, we see so-called cosmic microwave background. When we remove Milky Way, we see this anisotropy. It's a radio picture, radio. And to study early stages of the hot and very dense universe, we need fundamental particle physics. We need to develop so-called standard model. Here, astrophysics is very close to the atomic physics. Thus, famous scientists who developed, for example, atomic bomb in Soviet Union, Andrei Sakharov, Yakov Zeldovich, they made their input to astrophysics as well. For example, Zeldovich, he explained, they developed theory of this accretion at the center of galaxies to supermassive black holes. There were times when quasars were discovered, and they explained why such energetic objects could exist in the universe. Sakharov worked on hydrogen bomb in Soviet Union, and he also studied early stages of the universe, so-called baryonic asymmetry. Why in our universe there are more matter than antimatter? This question is not yet answered. And finally, at the very beginning, 14 billion years ago, the universe appeared from somewhere. Nobody knows how it appeared, but there are some theories, theory of Big Bang, when you see everything was very hot, very dense, and very energetic. Then first stars, first galaxies appeared. But even before the Big Bang, there was so-called stage of inflation. Inflation, like in economics, when universe expanded with huge acceleration. And in a very small fraction of a second, its size became, let's say, million times larger. The developers of this inflation theory, there are such names as Andrew Linde or Goods in the United States, or Stravinsky in Russia, developers of the inflation theory. They are trying to look at the very early stage of our universe and now they think that there was no time before it, there was no space before it. But some theories say that there are many universes. It's a so-called multiverse concept in the framework of chaotic inflation. People study initial conditions and they come to the conclusion that universes are born contemporary. And even now, new universes appears, but we don't see them. They appears in different uh, different dimensions. In different dimensions appear new universe, and this process of of universe born, born and born and born again continues. Now we come to the field of philosophy again. We know what we see, what really exists. We can think about something which could exist but cannot be observed. But where is the border with what with what doesn't exist? How to distinguish in our theories between what exists, what can exist, and what doesn't exist in reality? This is a difficult question. We are too small on Earth to answer all the great questions of our world now. But if you study mathematics, if you study physics, if you are interested in science, if you are interested in communication, you will see new and new and new discoveries in your life. And I recommend you, young people, also to apply for International Astronomical Youth Camp. It's a kind of gathering of young people interested in astronomy. There is entertainment, there are observations during night, very good equipment, telescopes, a lot of fun. You can find internet web page IAYC and apply for next year. This year they will meet in Spain to observe eclipse. And next year there will be another location. I visited this camp 3 times and I have very good memories. Thank you. That's all for today. Thank you for your attention. Questions if you have any.
Hey, Leonid, has been outstanding. Thank you very much for your time and your guidance in what is astronomy. You
Not
see,
at all.
yeah, there is a lot of question, but I have one that is, since I'm an electrical engineer by nature, and I would like to ask you one question. It must be a silly one, but probably it's not. You see, the size of the electron in space is the same size of the electron here on Earth, what we know about it, or we are talking about different size?
The size of electron.
Yes.
All questions about size of particles can be answered under the frame in the framework of actually there are no particles, there are only waves, as we know.
Yes, well, yeah.
Once one famous theoretician from the Institute of Theoretical Physics in Moscow made a big talk about Higgs boson in at my institute. And when I tried to ask him, is there any contradiction as in the books about waves and particles, he answered, there are no particles, there are only waves. This,
Wait, what?
this is a framework of quantum mechanics, and quantum mechanics was developed when relativity was developed at the beginning of the 20th century. Such names, Heisenberg and De Broglie and Schrödinger developed this theory. It's a good math. You can get all the orbits, all the measures, all the sizes and wavelengths and structure of matter from the eigen values of Schrödinger equations. And I am pretty sure that even at distant regions of the universe, even at another galaxy, even at that galaxy the Hubble Space Telescope observes, Newton law is the same, quantum
Okay.
mechanics is the same, chemistry is the same. We see in the spectra of these objects presence of hydrogen, helium, presence of lithium, and of course up to ferrum, up to iron. Everything can be created inside the stars. In the early universe only hydrogen and helium and a little bit of beryllium and lithium were created. This according to periodic system of Russian scientist Mendeleev, who worked in St. Petersburg. Foreign scientists never mentioned Mendeleev, but it was developed by me. So chemistry is the same, physics the same, sizes of particles the same. But the problem is that energy is sometimes very, very high. During accretion to black holes, during supernova explosions, energies are so high that all the following periodic system can be synthesized, but even contemporary Large Hadron Collider, our facility built for billion of dollars on Earth, it can reach only 1 tera electron volt of energy. When particles collide, 1 tera electron volt. We discovered boson, Higgs boson, but in the universe, processes are much more energetic. And those friends of mine who study, for example, high energy particles which come to Earth, they can see this bubble at our galaxy. This bubble appeared when the central black hole was active. Now our black hole is sleeping. It doesn't eat matter. There is no supply of matter to it. So it's like sleeping. But several, maybe million years ago, and maybe in the future, in 1,000 years, pretty sure that some matter will come to black hole and feed it. Then there will be release of very high energy particles. And one of historical example of such process is this gamma ray bubble at the axis of our galaxy. So actually, I don't. I know that still now there are some contradictions between classical and quantum mechanics. For example, the size of the orbit of electron calculated using classical mechanics like orbital, it has the same order, but actually real orbit differs from what is expected from classical. I mean the size of the electron orbit in atom. About the mass of electron, about the size of electron, you can find calculations in quantum mechanics, and I am pretty sure that in our universe, I am not speaking about other universes, there could be other universes in this multiverse cosmos which don't have life, which do have different p number, different Planck constant, different physics, different dimensionality of space. It's possible. But in our universe, physics, chemistry, size of electron, everywhere the same. But still, there are unanswered questions about dark matter, dark energy, and something which goes beyond the standard model of particle physics. Contemporary astronomers sometimes remind physicists, specialists in particle physics, especially cosmologists. But once again, astronomy is very wide. And if you are electro engineer, you can work with telescopes, develop equipment, develop new receivers. It's very interesting work how to detect all this. If you are more in theory, you can study theory of relativity. You can go to my colleague Sergei Kopeikin to Missouri. He works there, one of the best specialists in relativity. He writes equations with pencil. He asks me if I know any new alphabet because there is no enough letters in all alphabets for this equation. If you are theoretist, but there are very many applications for all kind of professions in astronomy. If you are interested in this, that's my opinion.
All right, thank you very much. That was an outstanding response to my question. Okay, what about any other question from the audience? Because we are old people, but the audience is young, is the next generation.
Yes,
If
doctor.
yes, go.
I have two questions to the doctor Yuri about the Leonid Zotov. My first question is, in Yuri Gagarin times, how did astronomers prepare for the challenge of sending the first human into space?
Well,
Yeah, Maylin, okay. I just finished reading one book about space, cosmic space exploration.
yeah.
Oh, it's not easy to answer because there is a huge layer of history under that. There is competition between Soviet Union and United States. There is competition from the point of view of science. There is competition between the armies because we need a rocket to send ballistic weight around the Earth. And the only thing I can say, astronomers at our institute, they work together with engineers, with Sergei Korolev, for example. They had programs of observation of the first satellite. They had special cameras. They received signals from satellite. They calculated the orbits. For example, when Apollo, American astronauts, was sent to the moon, we didn't actually know exactly gravity field of the moon. This attraction, because different layers have different density. And depending on the density, some regions of the planet, for example, Mercury, it's very similar. It has craters. Red regions attracts more, blue regions attracts less. And orbit around the moon, around any planet, it depends on its on how well we know gravity field. This science is called gravimetry. And my department at Moscow State University studied gravimetry, including the gravimetry of the moon. For example, there was a question raised how to land equipment on the moon so that it will not be broken. What it means? The answer was it could survive acceleration of 1 meter per square second. 1 meter per square second, and if you jump from the third or maybe fifth floor, will you survive if you jump from the third floor? equipment should survive if it land on the moon with such acceleration. And our colleagues, leader of my department, Sagitov, he wrote a book, Lunar Gravimetry. How to did this, how to measure precisely gravity field. Besides, you need cybernetics, because without control, you cannot land spacecraft on the moon. You need control. And of course, this theory, actually, it was developed by Norbert Wiener in United States and Andrew Kolmogorov, famous mathematician in Moscow. Kolmogorov, for example, calculated when there was a war with Germany, he was invited to St. Petersburg to calculate all the ballistic properties, how to defend St. Petersburg from German army. And these were statistical tables, calculations. It was all in one, space development, problems of gravimetry, problems of detection of signals, cybernetics, theory of probability, engineering, electrical engineering. And I must say that leaders of this industry, maybe it's not proper term, leaders of this field of industry, space exploration, Yuri Gagarin, they were very serious people. They checked everything for tens and tens and tens of times to make all the program guarantee that nobody will die, that the Gagarin will return to Earth, sorry, that everything was checked many times, and people worked from their heart, they spent their best, the forces and everything they input into this. It's a top, I would say, of human, how to say, top of human abilities. Young, very ambitious people. I wish you also to be ambitious, energetic, and pursue your goals in life and reach the best you can in your life.
Great, great, Leonid. I think, Leonid, we have to see the student has their report to present. So if you want to go, that's perfect. But if you want to stay to listen what they are doing, it's going to be just a short presentation from the student. I invite you to stay.
I
Okay?
will turn off my picture with this Asian Samarkand in
No,
Uzbekistan.
that's beautiful. That's an
Yeah.
outstanding. You see, to me, you see where the Muslim architecture is one of the most beautiful architecture in the
It's
world.
very old architecture, and very famous astronomer Ulugh built
Yes,
this. This
yes,
was actually, if you will be scientist, you will see very beautiful places on Earth. Pretty
yes,
sure.
absolutely. All right. So are you going to stay them in the connected?
I will stay, but I will turn off my video.
Perfect. Thank you, Mike.
My
Okay,
pleasure. My pleasure.
before you go, we would like to take a picture. Barak, can we ask
Picture,
everybody
yes.
to show their faces so we can have a picture of this meeting? You see? What about that? Okay.
Yeah, good
What
idea.
about let's show your faces, all the people who are connected now, please. All right. Yeah. So because Barak he's going to take a picture of us. Wow.
Yeah, I don't see a lot of camera opening right now, so waiting for all of you to
Yeah,
please.
I think we are not too many, you see. Eric is there. Let's see. But what about Maylin, Fairly, Einar, Leandro? All right. Yeah, because this is for our web page. Okay, we are going to present this. Leandro, are you there? Leandro. Einar.
Yes, but I have problems with my camera.
Okay, yeah. Fairly, do you are there? Maylin? Yeah. Leandro? Okay, he has problem. Yeah. I think Fairly, Marlene. Marlene, are you there? Yes. Yeah, I think we are all right. Let's take that. Let's take this picture. Perfect. Barak, are you ready? Barak?
Yes, I took the picture, so we are all set.
Okay, perfect. Okay, now anybody who is a volunteer to present what they did during this week, you are welcome. Who is coming? Melissa? Eric? Remember that you had to present me, you see, your report.
Dr. Juan, should I stop the recording? Because we just want to upload.
Okay.
Yeah.
All right.
Okay.
I think that will be perfect for the presentation of
Yeah.
Dr. Leonid
Leonid.
Zotov.
Yeah.
Great. Yes. You can